A Wheatstone bridge is a nice electrical construct that looks something like this, with four resistors R1, R2, R3 and R4 connected in this fashion and through a source of voltage. The key point here are the points B and point D, and the current flowing to the resistor connected between B and D. We try to arrange these resistors R1, R2, R3 and R4 in such a way that there is no current flowing in this resistor. And this is possible when the voltage at B is equal to the voltage at D. And it happens under certain conditions or proportional values of R1, R2 and R3 and R4. We will derive this formula and learn about this. Make sure you go through the whole of this video to understand it completely. So we will work on few examples as well. Before we go into the details of the derivations and formula and others, let's see this simple construction which is a part of the Wheatstone bridge. We have a voltage source V and we have resistors R1 and R2. The one thing we need to keep in mind is that the voltage at B is given by V multiplied by R2 divided by R1 plus R2. As an example, if we have a 12 volt source here, we have two resistors 4 ohm and 2 ohm, then the voltage at B is given by 12 volt multiplied by this 2 ohm resistor divided by 4 plus 2, or 4 plus 2 is 6. It comes 2 into 2 is 4 volt. The voltage at B is 4 volt. Now let's go back to the Wheatstone bridge example with some real values put into this whole Wheatstone bridge. And the focus is again the point B and the point D. With this 36 volt applied, the current starts traveling through this, comes here and goes into this home branch and returns to 3. The voltage that is at A, it also flows in this through this branch and comes to this and 3. Now voltage at A is 36 volt, the voltage at C is 0 volt, and in between those A and C, these two branches, the voltage gets divided and has some value at B and some value at D. And the voltage at V will depend upon the proportional values of this R1 and R2 or R3 and R4 for D. Then voltage at B is given by this 36 volt multiplied by the lower branch 4 ohm divided by 4 plus 2. 4 plus 2 is 6. 36 divided by 6 is 6 into 4 is 24 volt. Voltage at D is 36 multiplied by 6 ohm divided by 3 plus 6, 9 ohm. 36 divided by 9 is 4. 4 into 6, 24 volt. So voltage at B is same as voltage at D. In other words, if we connect an ammeter here, or if we connect a voltmeter between B and D, it will show 0 volt. If we connect an ammeter here and a resistor here, the ammeter will show no deflection at all. But even if we slightly change this 6 volt to say 7 volt, there will be a flow of current because B and D are not balanced. And that is what we see in this next example. Let us say we have rearranged this resistor, so we have 6 ohm here and 3 ohm here. Now voltage at B will be same 24 volt, but voltage at D will be 3 divided by 6 plus 3, 9 multiplied by this 36 volt. And this becomes 6 plus 3 is 9, the 4 into 3, 12 volt. The voltage at B is 24 volt and voltage at D is 12 volt. So we saw that if we change any of these resistors, then there is a flow of current in branch B and D. So this is the principle that we need to keep in mind, and in the next video we are going to derive what are the relationship between R1, R2 and R3 and R4 so that this bridge stays balanced, and by balanced means there is no flow of current between points B and D. So to do that, we need to calculate VB, that we saw as V multiplied by R2 divided by R1 plus R2. Voltage at D in the same fashion is V multiplied by R4 divided by R3 plus R4. Now the condition for no flow current between B and D is that VB is equal to VD. Same voltage, so there is no current flow between B and D. And we substitute the value of VB and VD from here, and we get V multiplied by R2 divided by R1 plus R2 is equal to V multiplied by R4 divided by R3 plus R4. V cancel out, so we get R2 divided by R1 plus R2 equal to R4 divided by R3 plus R4. Now we can rewrite this as, we can put negative sign on both of the sides, it does not change this equation, and then we add 1 to both the equations. If we rearrange the things in a different fashions, we will finally arrive that R1 divided by R2 is equal to R3 by R4. I have not done this rearrangement quite right here, but I will leave it as an exercise for you to show that R1 plus R2 is equal to R3 for R3 divided by R4. So the key thing is that the ratio of the resistor R1 divided by R2 should be equal to R3 divided by R4. Now we are going to do an example. Find the unknown resistor Rx and assume that bridge is balanced and no current is flowing through the resistor R. Let's say we have a rheostat and we are trying to change the value of this Rx, which is a variable resistor, which I indicated like this, and we keep shifting it and bring it to the point where there is no current is observed in this branch. Then in that case, we can find out the value of, and thereby, since we know the value of these three resistors, we can find out the value of Rx. So to do that, we know that this R1 divided by R2 is equal to R3 divided by R4. So we have 15 divided by 30 equal to 7 divided by Rx. So this becomes 2, and if we rearrange, then we get Rx is equal to 14 ohms. So I hope you find the understanding of Wheatstone bridge interesting. If you have any comment, leave it in the comment section.